Welcome back, everyone. After we just practiced the simple binary compounds and the ones including a transition metal, we're going to add one more layer to this with using polyatomic ions. Remember that all of your polyatomic ions can be found on the back of your periodic table. The chart that's right here is not full or complete, but includes some of the most common ones so that you can kind of start memorizing or becoming most familiar with the ones that are used most often. But the complete chart is on the back of your periodic table. The one that you have on the back of your periodic table is exactly the same as the one that's on the back of your testing periodic table, so there shouldn't be any discrepancies there. But always, if you have a question, feel free to ask. With our polyatomic ions, things with polyatomic ions look really complicated because the compounds are big and they contain a lot of elements, and sometimes they look really complicated because they've got many different elements, many different numbers, and then there's a charge number, and some of the names are really weird sounding, so it can be a little bit overwhelming. But remember two different things here. Number one, your rule for ionic compounds is still just to crisscross and reduce for making a formula. And then naming polyatomic ions is really simple because remember that I told you cannot change anything about a polyatomic ion. So where that benefits you in the names is that they all just stay the same. So you literally just read it right off of your ion chart and you roll with it. So let's get a few details in here with the formula writing and then also reviewing some of the names or some of the naming conventions. So with a polyatomic ion, these guys, if you look at each individual compound, they're actually all covalent. So each of them is a molecular compound that as a group has gained or lost an electron somewhere. So it's put together differently than if everybody were to have all of their electrons. So the way that they structure and how they share electrons are slightly different. And as a result, they get, as an entire group, they get a charge, they get an oxidation number, as if they were just a regular ion of a single element. So they're covalent, but they're acting ionic. Okay, again, that's because that as a group, they've gained or lost electrons somehow. So the way that we're going to treat this, remember I said you cannot change anything about them at all. You can't change their formula, you can't change their number, you can't change their charge, nothing. So as a result, remember we've talked about this in a couple of different contexts where you are not going to distribute in any way. You always have to keep the grouping together. And as a result, we put parentheses around the compound whenever we need more than one of them. So in other words, whenever we need to add a subscript. Okay? So whenever we need to add a subscript, we put parentheses around it because we're never going to write it like this. So in other words, we do not distribute. Now we do distribute when we count individual atoms. So if I asked you how many oxygens there were, I have 2 times 4. So there's 8 oxygens there. But in terms of writing the compound, I cannot change how that compound is structured. So this formula represents the structure, but then when I'm counting atoms, mathematically I would count all of that and use the distributive property to do that. But from a formula writing standpoint, we keep it all structure-based and we do not distribute. So we're always going to keep those polyatomic ions grouped. Okay, so we're going to group those polyatomic ions with those parentheses, not distribute. So here are some common polyatomic ions in this chart here. And again, there are really no naming rules for polyatomic because all names stay the same. for polyatomic ions. Okay, so when we go to name them, if it's OH, I'm just going to write hydroxide. It does have an IDE ending, but we can see that it's polyatomic because it's O and H together. You'll also see ATE endings, ITE endings. Those are the two most common ones. We do have one over here. This is the only one with a positive charge. Notice that all of these other ones have negative charges. This is the only one that has a positive charge, and it has an ium ending. Okay, so all of your funny endings are usually found in your polyatomic chart. So let's practice these a little bit. Scrolling down here, we've got some examples. So aluminum is a regular element. So I look on my periodic table and I find that aluminum is in group 3, so it's a 3+ charge. Nitrate has a funny ending, so that should clue me to look back on the back of my periodic table. And I should see that it is NO3, and it has a -1 charge. So when I crisscross, whoopsie, I didn't realize it erased. 1 second. Aluminum, 3+, nitrate is a 1-. Okay, when I crisscross those, that 3 is going to come down on the entire grouping of NO3. So my final answer is going to be 1 aluminum and 3 entire groupings of NO3 or of nitrate. Here I've got calcium. Again, calcium is just a regular element. So I'm going to look on the periodic table. Remember, spelling does count in this unit. Calcium. And then OH, those are more than one element together. So as a result, I'm going to look on the back of my periodic table and I'm going to find that it's hydroxide. Again, by coincidence, this does happen to have an IDE ending, but I didn't put it there. It's there on the ion chart. So I keep it. Remember, you cannot change anything about these guys' names. Now in C, I've got all kinds of things going on here. I have copper, which is a transition metal, and I have sulfate, which is a polyatomic ion. And again, I know that because 8 is not an ending I'm allowed to do, so it must be on the back of my periodic table. So copper 2 tells me that that version of copper is a 2+ charge. So I'm going to carry that over. It does not mean that there's 2 of them. It means that its charge is 2+. And then sulfate on the back of my periodic table is SO4, and my ion chart tells me that it's a 2-. So when I crisscross that, 2 is going to come down on copper, 2 is going to go down on sulfate. But 2 and 2 are going to reduce to 1 and 1. So I'm going to have copper, one of them, and sulfate, one of them. Notice that I did not use parentheses around sulfate here because I don't need more than one of them. I didn't need to add a subscript. When I see that my charges match 2 and 2, I know that that is going to reduce down to 1 and 1. Even if it was 3 and 3, it would still reduce down to 1 and 1. The point is, those charges are already balanced. I have 2 in the plus category, and I have 2 in the minus category. So it's always going to reduce down to 1 and 1. Now I'm going to go over here. We've got silver and nitrate. Silver is just silver. Now silver is a transition metal, but remember it's one of the ones that only has one oxidation state. So it's always a +1. And I don't need to write a Roman numeral because that's the only option. Nitrate is NO3. It's polyatomic. So I just write what its name is and I can't change anything. Now, remember ammonium. Ammonium was our one and only polyatomic that can sit in this cation spot. So ammonium, I'm told, is a +1 charge. And then phosphate is a 3- charge. So I've got NH4, which is a +1, and I've got phosphate, which is a 3-. So when I crisscross that, I'm going to need 3 total groupings of ammonium, and I'm going to need 1 total grouping of phosphate. So NH4 is going to go in parentheses because I need 3 of them. Phosphate does not need parentheses because I only need 1 of them. And then here I have ammonium again. NH4 is just ammonium. And then chlorine is just regular old chlorine. So since it sits in the second spot, I know that I'm going to have to add my IDE ending because the second name always gets the IDE ending if it's just a regular element. So you guys are going to go ahead and practice some more with their polyatomic ions, and then we're going to move on to a game that we're going to play for the second half of class. If you have any questions, come up and ask me. Or if you're doing this because you're out, using the video because you're out, please message me and I'll get back to you as soon as I can.